Today we're now going to start to take a look at voltage, but in two dimensions. So what we have here is we have two charges at the bottom. We have Q1, which is a positive charge, and Q2, which is a negative charge. Now to find the voltage for part A, it's really pretty simple. It's 30 centimeters, it's a straight shot. V is K, Q over R, and we're going to do that in a few minutes. The trouble is finding it to, and I hope my draw line's okay, and it's all right, finding it to the second charge. Because it's not 52, it's not 30, it's along this hypotenuse. So we need this distance. I guess we'll call it C. But that's easy enough because it's just Pythagorean theorem. 30 squared plus 52 squared. And then we'll have to take a square root, and I don't know what those numbers are off the top of my head. 30 squared is 900. Plus 52 squared is a really big number, 3,604. Don't forget the square root. So it's about 60 centimeters away. A nice round number, 60 centimeters. Before we get into the more involved math, let's also think about, well, what's this going to be in terms of positive or negative? This is a positive charge. It will have a positive voltage. Its voltage will be greater than 0. This is a negative charge. It will have a voltage that's less than 0. So these two voltages should end up canceling. The really nice thing about voltage is we do not need to worry about angles. We do not need to worry about a resultant triangle when we're all done. So it says use Pythagorean theorem, which we already did. So the voltage at point A is V1 plus V2. I'll just go back here and show you. So whatever this voltage is, plus this voltage coming from that direction. One is positive and one is negative, so they will end up canceling each other a bit. So V is KQ over R. The K is the same K we've been using, 9 times 10 to the 9th, Newton meter squared over Coulomb squared. Now this was 50 microcoulombs. Now, I have it as 5 times 10 to the 5th. If you want to put it as 50 times 10 to the minus 6, go right ahead. That's no problem there. The distance was our 0.3 meters. We don't need to square it. So we do a little math. We let the computer do the math. And we get a pretty high voltage there. That's actually 1.5 million volts. For V2, we need to put the negative in. Notice it's a negative charge. I put the negative in. I had to include that. So I now just do KQ over R, but it's much further away. So as we would expect, the voltage is a lot less, half. Then I add them together. And it turns out that the positive voltage wins. So that means at that point, if we could bring a voltmeter and get a reading, and that's trickier said than done, let's have a little meter here, we would get a reading of 7.5 times 10 to the 5th volts. Because the positives and the negatives canceled each other out a little bit. Oh, now we got one that's perhaps a little more tricky. It's the same charge, positive 50 microcoulombs and negative 50 microcoulombs. And we're going to have to go ahead and figure out, well, what's the voltage if we were at point B? Now, there's no charge at point B. Point B is just a point in space. And I think we can see here that we would need to calculate the distance. So that distance, we'll just call it c for now, would be the square root of 26 squared plus 30 squared. All we're doing is using good old Pythagorean theorem. And I'm getting 39.7 centimeters. So that's our 39.7. I have it on the next slide here. 39.7 centimeters, 39.7 centimeters. Did I leave a blank slide to write on? Yeah, I did. Well, let's see, maybe we can even put it on here. So let's call this V1. KQ over R. Let's see, so the distance is 0.397 meters. K is 9 times 10 to the 9th. And the charge is 50 times 10 to the minus 6. It's positive. Positive charges give us a positive voltage, just like we might expect. And that's a really big number. Got to put that in scientific notation. 1.13 times 10 to the 6 volts. Let's see what happens with V2 here. It's still KQ over R, 9 times 10 to the 9th. But it's negative 50 times 10 to the minus 6. And you might be able to see what's going to happen here. And it's symmetrical, 0.397. So V2 should work out to the same number, but what's going to be different? It's going to be negative. So V at point B is V1 plus V2. And I think you could easily see, I hope you can see, 10 to the 6th minus that. There's no voltage there. It would be 0 volts. So it's like you wouldn't feel any charge happening in that point. Oh, and I already have the math here. Oh, I must have rounded it to 0.4. That's okay. And let's see, indeed, we get our 0 volts. And then we'll do one tomorrow where things aren't as evenly balanced as all this.